What did I do there? Sorry? I pull the 205 on the outside because it's a constant. Okay, it's a constant, so I can pull it out of the sigma sign. And then I just squared 205, which gives me 4 over 25. Okay? You guys with me on that? Okay. So now look at this part here, okay? Look at this part here, which is kind of like this part here. Okay? Which goes back to those formulas that Nate just pointed out, and I told you that we've been there, done that in chapter 8. So we need formulas like what on page 820, okay, on page 820. Okay, so here are, these are some of the formulas that I'm talking about, okay? This one here, and you obviously know what this one is, okay? Or I think it's a C, they use a C in here. Okay, so in other words, those 5 or 6 formulas, frankly, I expect you to remember 1, 2, 3 at least, maybe not 4, but 1, 2, 3 for sure. You got to know, okay, and I have tested you on this, okay, in chapter 8, so we've been there. So we need those kind of formulas, and this is the reason why we need those formulas, because like I'm saying, what we're going to do is take this formula and do this to it. Okay, this is what we're going to do to it. Okay, which is exactly what Josh had me do on number 15. Okay. So let's proceed with this. So the first thing to do is like what that problem had suggested, which was to write things as a rational function. So what is sigma I equal to? Sigma I 6. What is this first one equal to? What? Lizzie? Sorry? 6n. And then what is the other one equal to? Go back to page 820. Look it up. Look it up.
N plus 1 plus 2 minus 2n plus 1.
All over?
All over 6.
All over 6. Can you guys read this, or can you actually write it yourselves? Are you guys okay on that? I'll rewrite this, okay? Hopefully I don't get into a crunch again. Something's not sounding right to me. Something doesn't look very good to me. The 6n doesn't look good to me. Because as n goes to infinity, that's going to blow up. No, okay. Okay, well, we're okay. We're okay. I think I need more space to write on. It's going towards infinity, just like in problem 15 was. Okay, just like what was in problem 15. Okay, so I need to write this as a rational function first. Okay, so someone help me write this as a rational function. Can I reduce the denominators here? Is that okay? And then I get 25 times 3 times 6n. Can someone do that math for me, please? 25 times 3 times 6. Come on, get your calculators out, dude. Oh, why are you guys being so freaking lazy today? What's up? 450n. Yes? Minus, can I FOIL the upstairs? So the upstairs is going to be n squared plus n times 2n plus 1. Zara, can you come and sit here, please? And the common denominator is, sorry? 75, thank you. I'm not very happy with this somehow. I don't know why. Things are not looking very good to me. Sorry? Things are not looking very good to me because I would have expected a 1 over n somewhere. Oh! Boom! Why is there a 5? Why is there this 5? What should that be? Okay, how did we get that 5 in the beginning? How did we get that 5 in the beginning? From Friday. How many did we have on Friday? Yes, it was 5. But what do we want? Where did this guy go? He even changed the background on me. Okay, Bill Gates, stop it. Ha! Okay, I am screwed basically here. Got to start all over again. That's okay. That's okay. I'm doing the work. You guys are sleeping, so it's all okay. I don't mind doing it. Do you guys mind sleeping? It's okay for me to work? Yes? Start over again? Okay, let's do it. So let me go to the next page because that's better. Is it better? No, this page is good. Okay, I'm going to work on this problem here, okay? So we need to fix this. I had a feeling it wasn't looking good. Okay, so the first thing I need to do is change this. Change this to infinity. And this guy would be infinity as well. Except it won't be infinity, actually. That's not the right way to do it. This is the right way to do it. I'll make that an n. Make this an n. Make that an n. So then this guy would be an n. This guy would be an n. This guy would be n squared. Okay? So now what I want is I want limit as n goes to infinity of this stuff here. So that's 2 over n sigma I equals 1 to n 6 minus 4 over n squared I squared. Okay? Guys got that? Okay, I want you to use the formulas on page 820 to go simplify this and write this as a rational function. Just like I did in number 15 a few minutes ago. Okay, so I'm going to pause here, get you guys to do this. Okay, has everybody gotten this far? Now I tell you that you don't need to FOIL this stuff here. You don't need to, and I'll tell you why in a minute. Okay, I'll tell you why in a minute. Did you get this far? Did you get a 12 by itself? Do you see where the 12 is coming from? Need I explain that? Hello, anybody home? Everybody see where I'm getting the 12 from? No, Priscilla? All you are doing is timesing this by this. You are really sick, Priscilla. This is not something you'd miss. Okay? And the reason why you don't need to fold the other stuff is I'm going to be invoking the rules that Emma just told us. Okay? Emma just told us the rules that the degree of the numerator is the same as the degree of the denominator. Then the limit is just the ratio of the coefficients. You guys got me? Okay? Now, does this guy depend on n? Does this guy depend on n? Does 12 depend on n? No. So then the answer out of there is going to be 12. The answer from there is going to be a 12. Okay? This other guy, what's the degree of the numerator? What's the degree of the numerator? Remember, the degree is the highest power you're going to get. 3, what do you think is its coefficient? 8? Is everybody there? No? Got it? What's the coefficient of the downstairs? Hello? 3. What does this equal? (28/3). So remember on Friday we did how many rectangles? 5. You got an answer there? What was the answer on Friday? What was the answer on Friday, people? I'll be with you in a few minutes. Okay, let me get the answer from Friday. Did you guys take notes on Friday?
Yeah.
Can you look that up and see what your answer was on Friday? Oh my God, what's up with you, man? Wow, what you guys doing? You guys are killing me. Yeah, dead week, not like you are dead. No. You got finals next week. Yeah, so you're going to, crank it up a notch. It's like, what do you think OKC does? Do you think they're going to sleep after the game too? No, they're going to take it up a notch. What was the answer on Friday? 8 and what? 8.18? 8.48? Something? What is this equal to? 9.333. So if you had taken, instead of 5 rectangles, if you had taken 10 rectangles, you're going to get closer to this number. Okay? And so the most exact answer, the precise answer, no approximation at all, is exactly that. I'll be with you in a minute. So the area that we were trying to find on Friday, you guys remember that picture? Do I need to bring that up? It was this area we were trying to find. We did that first with 5 rectangles. Today we did it with an infinite number of rectangles. We got an exact answer, 28/3. No questions about it. Question?
When you got from, it says 4/3n squared times 1. Shouldn't that be 2/3n squared?
Yeah, but then there's another 2 outside.
Oh, I see.
Okay? All right. And then there's another 2 here. So there are 3 2's there. 2 times 2 times 2. Okay? That's how we got 8/3. You with me? Okay? All right, I'm done with this. Today's homework 33 through 43 is all problems like this, where you're supposed to write it as a rational number and then take the limits. Okay? All right.